Okay, welcome to another episode of the Network Cabling ELEC 1013 class, Venture College, London, Ontario. 2025, did I mention that? Yeah. All right. So today we are going to tie some loose ends from the previous classes just before we release the test for this class. And this is the first topic that we need to cover. All right, broadband connection versus baseband connection. All right. How do I begin with this thing if you had nothing to do with it before? All right, broadband and baseband connections are types of transmissions that use different types of multiplexing. All right, so now here's the multiplexing that I have to explain. All right, we're having fun here. Let me fire up my board. So yeah, let's explain the idea of multiplexing first. Hmm. Right, new file. Come on, that should be it. We're good. We are good. All right. So I'm just going to explain things a little bit different than the previous class today. Let's see, between those two, we should get some good idea. All right. Let's say we only have one pair of conductors, one communication pair, and we want to transmit several telephone conversations just over that one pair. Well, first, you could put those conversations on different frequencies and have a tuner at both ends. Well, the transmitter would encode the frequency onto some sort of a whatever carrier frequency it would be, and on the other side would be a tuner to catch that particular frequency, and you could do it 3 times at different frequencies, and you're going to have a tuner that would select the particular one. So that would be frequency division multiplexing. But let me show you something else. Let me show you something that's called a time division multiplexing. Let's say you have 1, 2, 3. You could have 100, but let's just do 3. Okay. 3 points on one side, 3 points on the other side. And between all those, we're going to have a ground reference or return path, common return path. All right. So over here, we have telephone. Let's just do telephones. A telephone set connected here and a telephone set connected here to that one, let's say here. And of course, those telephones would have a ground connection as well. That would be the ground start, which is not used anymore, but that's just for the simplicity of things. And the same thing is going to be happening on the other side. We have a telephone, which here's another telephone. All right. And it's also, so it has both of them have both of the sides have been connected to the ground, so they have a common ground thing. All right. And we have another wire going between those 2 points. But this here, on this side, there is a dial. There's a switch. And there's a switch here that switches between those. So this switch can connect these two together. Of course, they will have to be synchronized. And you can switch the switch and that one at the same time to connect these two, or you can switch the switch and the other one at the same time to connect these two. So, and if you give them, let's say, 5 seconds each to say what they want to say, and switch to the other one and switch to the other one. So each of those would have to wait 10 seconds before they can speak to 5 seconds to each other. Well, that's one way of doing it. And yes, it's a time sharing of the line, but it's not a very efficient way of doing things. However, if you make those switches, one and the other, switch extremely fast and just rotate between these 3 points and rotate in between these 3 points and do it very fast and in a synchronized way. So if that switching would happen extremely fast, all 3 of those conversations would be able to carry on without even noticing that there's switching. So here is something that's called the time division multiplexing. This line would carry one conversation at a time, but because the switching would be very fast, nobody would even notice that the switching is happening, and they will be able to carry a proper conversation with each other. So that would be a time division multiplexing. Multiplexing. Yeah. All right. So that was also associated with something that's called the baseband. But before we talk about the baseband, we're going to talk about the broadband. All right. Now let's see what I had to say a couple of years ago, or maybe more. Broadband internet service. Okay, not only internet service can be brought to you by broadband type of transmission. The most common one that you probably are using all the time is when you're driving in your car and turn on the radio. Excuse me. Turn on the radio, and what's happening? Well, there are multiple radio stations all over the place, and all of them are shooting the signal with different carrier frequencies into the air. So the air is filled with a bunch of signals all at the same time. Now, what you have in your car, in your radio, the radio has something that's called a tuner. The tuner can tune to the specific frequency of the specific radio station, and by doing that, the radio can receive a signal only to the station that the radio is tuned to. But nevertheless, all the frequencies are present in the medium, which in this case is air. Okay? So this would be something that's called a broadband connection through the air. You can do broadband connection through a cable. Remember when we were talking about the coaxial cable and what are the designations of coaxial cables? RG. And RG stands for radio guide. So you can transmit, broadcast the frequencies over the air, or you can transmit the frequencies enclosed in a coaxial cable. In fact, up till 80s, mid 90s, beginning of the 90s, actually towards 2000s, the television signal was provided to all of us subscribers In a broadband type of connection, well, in a way that all the channels were present on the cable or in the cable all at the same time. And the television tuner would just tune to whichever channel, TV channel wants to tune. And the switching was happening immediately. As soon as you press the button on the remote control, click, there's a channel. Click, there's a channel. Click, there's a channel. Now, right now, if you switch the channel, there's a bit of maybe 1 second delay, half a second delay between the times that the television set makes a connection with the appropriate program channel, and then it just makes it happen. But also, internet is brought to us in a broadband type of a connection or delivery. Just as a reminder, there is the signal that is brought to you from the outside towards your house, for example, or to any kind of building, to the demarcation point of the building. Now, what is the first thing that it meets? It meets the modem. Modem stands for combination of two words, modulation and demodulation. So the modem is a box that is modulating and demodulating all at the same time because signals are traveling both ways through it, both ways. So since it's modulating and demodulating, somebody had a bright idea of calling it a modulation demodulation device. Well, modem. Okay, so they call it that way. Now, the signal on the outside, before it hits the modem, it's brought to us in an analog form. You could compare that to the channels on the radio station, of the radio stations. That's an analog signal. There could be digital intelligence, but the waves are analog. The carrier waves are analog. As I said, the intelligence signal, which would be the speech over the carrier, that's called intelligence signal, that could be encoded in a different way. Then, when the signal hits the modem, it's being transferred onto something that's called a digital signal. And you know the rest of the story. You can use the internet. So let's say broadband internet service. And I said that it's the most used form of internet access because of its high access speed. Now we have signals in the range of 30 megabits, 60 megabits per second. High speed. Mind you, what's considered high speed now is a super high speed to what was considered high speed not too long ago, like 10 years ago. 5 megabits per second was considered high speed. Comparing to what? Comparing to the regular old dial-up modems. But one thing at a time. I'm getting ahead of myself a little bit. So broadband internet service is the most used form of internet access because of its high access speed. It is offered in 4 different forms. DSL, which is the signal, it's called digital subscriber line. And that is the signal that is superimposed onto the POTS telephone line. That's the DSL. It could be delivered to us through the medium of fiber optics, cable. Well, the telephone cable is also a cable, but cable popular is called that. When you hear cable, that they mean coaxial cable, and satellite. So that would be the air. Now, the old dial-up connection is the only non-broadband internet service available. It was just a dial-up. You make one-to-one connection and you communicate. But you probably don't remember that because you're too young, of course. Um, I wish I could say that, but you don't remember those times when the internet was sort of first introduced on the consumer level to us, and it would be just going through a phone line. Well, you get your laptop or a PC connected to a modem, and you want to make a connection to the internet. You take up the phone line. The modem would pick up the phone line just like the telephone would, and it would detect the dial tone. And if the dial tone wasn't there, it would try to hang up and pick up again to make sure that the dial tone is there. And it would just dial a number and be connected somewhere to some sort of service. And those were called bulletin boards. And it would make a connection. That was slow. The connection was slow, but to us at that time, it was like, wow, you don't only have the Sound Blaster speakers, or you can hear the music actually to the PC, but you can actually connect to the whole outside world. Doesn't matter if it was slow, you have a connection to the world. Oh, you can talk to somebody, or you can just get a weather report whenever you want. Don't have to wait for the TV programming to be telling you the weather report or buy a newspaper. That's how it was. So that was the old dial-up connection. That is a non-broadband because it was, well, quote unquote, you can say peer-to-peer connection. But at that time, when you were using the telephone, nobody could use the telephone in the household because it was taken up by the modem. Later on, DSL came up, and that was already a broadband because that DSL was superimposed onto the telephone line. You could talk on the phone and you can use internet both at the same time. That was a breakthrough. I mean, breakthrough for us at that time, consumers. It was a huge thing, sort of. Okay. So, and even though, let's say, the old dial-up connection is now, notice that I am not using past tense, and it's not a mistake. Is the only non-broadband internet service available, and even though it is cheaper, most internet, pretty much all internet users, are have moved now towards the faster broadband internet connection. By the way, when the DSL came up, 5 megabits per second was considered high speed. Now, 30 megabits per second right now is considered high speed, but kind of like normal. You don't want anything less. How slow was the dial-up connection? Well, if you wanted to download a picture, and usually that would be something amazing, like a extremely beautifully colorful picture of a parrot. Like you've never seen a parrot before, right? And once you click to download that one picture, will be a bitmap. You could go for a coffee and come back, and by the time you came back from your coffee, this thing would be towards the end of downloading. Oh yeah, just maybe one more minute. I'm going to see the colorful parrot. That's how slow those things were. Forget the video. All right. Ethernet signal, it's a digital signal because that's on the other side of the modem, on the inside of the house of the modem side. And the best delivery would be time division multiplexing, which would be a baseband, not a broadband. Baseband. It's all about the baseband, the baseband. Okay. Sorry. This will be the baseband. One at a time through the pair of wires, but because it's switching very fast, it feels like you're having 3 pairs. So that's a time sharing, baseband, time division multiplexing. Now, the internet signal type that goes from outside to your modem is in the form of broadband, which is not a time division multiplexing, it's a frequency division multiplexing. Let's expand on that. Broadband. Boom. All right. And here would be the baseband. All right. So let's analyze these couple lines here. Broadband connections are divided into channels. Here, let's say it's a coaxial cable. And here the thing that the mysterious MUX or DMUX, it's an abbreviation for multiplexer and demultiplexer. Just like encoder and decoder type of thing. So let's say you have 3 channels, you could have 100 channels, but let's say just 3 channels. All 3 channels are present in the cable at the same time. The demultiplexer, in the form of a tuner, would tune into a particular one and give you that one on the output, like a radio. There are some tuners or demultiplexers that would just have multiple channel availability, so you could fan out the channels all at the same time, and those will be connected to whatever parties they needed to be connected. So in broadband, connections are divided into channels. Each channel occupies a space within the spectrum of that medium that it can handle. It's called the oh, I'm really drawing a brain bubble here. Bandwidth. All right. I apologize for that. So whatever the bandwidth depends on the bandwidth of the medium, which would be the coaxial cable, and of course it has to have bandwidth that is huge enough to accommodate all the frequencies there, all the channels, 100 TV channels, maybe more. Of course, more. So coaxial cable does have a big bandwidth to fit them all at the same time, from lowest TV channels to the highest TV channel. As opposed to the baseband, you're only transmitting one channel at a time, so high bandwidth is not that required because we're transmitting one at a time, but we're switching between them very fast. Well, let's go back to this thing. All channels are injected to the medium, which would be the coaxial cable, for example, all at the same time, and they're present there. Communication between devices is established through tuning to a specific frequency. Thus, we're talking about frequency division multiplexing, as opposed to time division multiplexing, where no tuning is required because you're only transmitting one channel. So it's 99.9% true. Yeah, because sometimes you would just have to tune one with the other, but once you tune that, it stays there. You don't change the tuner. So that's why I say no tuning. I should have that thing in like quotes. Each communication link waits its turn to talk in a time-sharing manner. So we have 1, 2, 3, 4 channels going into the multiplexer. And we have 4 channels coming out of the demultiplexer. And we only have one link connecting them. So through that, you only have one pipe, sort of, one pair of wires. So then they have to be time shared, but because the time sharing happens extremely quickly, to human ear, if it's a voice communication, you will not even know that it's happened. Just like you're hearing my voice, you could be hearing other people trying to talk to different audiences. And if the multiplexing was happening extremely fast, you wouldn't even know. Or I wouldn't even know. So each communication link waits its turn to talk in a time-sharing manner. Each communication link occupies all the bandwidth of the medium that it can handle, which means the cable doesn't have to have as huge of the bandwidth as link for this type of communication, for the broadband communication. Because all the channels have to be fed, have to be fitted right in there. And over here, just one at a time. So the bandwidth of that link is not as crucial as the bandwidth for this link. And there is no channel division. For the baseband, that employs time division multiplexing, as opposed to broadband, that employs frequency division multiplexing. Now, remember when I was talking about the dial-up and I wasn't talking about past tense? This is how it was happening, and in some cases still is. Here's a PC, here's a modem. It was a different type of modem. It would be the modem that, if you ever saw that old movie, it was called War Games. It was about some high school kid who kind of hacked into the school system and to some military things and almost started the Third World War, things like that. It was the movies was done in, it actually hit the cinema. It was at some time 1983 or 4, something like that. So that was the type of modem that was being used by the public. So here's a PC, here's a modem, uses a telephone line to dial a number through the CO, local exchange, central office. Then from there, connection would be made, just like you were talking on the phone, through the wires, and it would be connected to another modem where this destination would be. You could connect PC to PC or PC to a server, which would be just a heavier version of PC. And the communication was slow. Well, comparing to what we know now. So let's see what I wrote a couple of years ago. Dial-up internet access is a form of internet access that uses the facilities of a public switched telephone network, what it uses telephone service, to establish a connection to an internet service provider by dialing the telephone number on a conventional telephone line. Dial-up connections use modems to decode the audio signals. So the communication happens through the audio signals frequencies that are encoded in certain ways. So they can be interpreted on the other side by something that understands that frequency language into a data to send to the router, computer, and to encode signals from ladder devices. Okay, it's a bit of a mess here. So modems would use audio signals to communicate with each other. Now, is it still being used? Well, yeah. 2 examples I can think of. If you go to some sort of a store that they don't have a network, it could be a pop-up shop or it could be some variety store that's maybe out of town that they have problems with internet or something like that, but they still have phones. And if you buy a chewing gum and you pay by your debit card, once you swipe your debit card and put your password or something like that, whatever PIN, it takes about 10 seconds for the transaction to go through, or maybe 5 seconds. That's a long time comparing to if the money machine is connected through a network, it just happens almost instantly. Now, that's one example. Another example is used also a retail example. Let's say there's a store, bigger store that has, well, semi-bigger, that has 6 cash registers. And a cash register is basically a PC with a money drawer and different type of display and different type of keypad. But it's a PC structure. Now, let's say, because when people are buying groceries or whatever else, That communication between that cash register goes to the network through the VPN, virtual private network on the internet, and it connects to whatever server it needs to connect to report the sale. If the network goes down, there's no connection with the server, and it's a bad situation because you really, really want that chewing gum and you can't buy it. So, to remedy that, 5 out of those cash registers are going to be shut down. I'm talking if the network fails, internet fails. And one of them is one of the cash registers is going to be designated as the failover one. So the money machine is going to switch from using the network to using a telephone line, and it's going to use that dial-up modem to dial the number to whatever server it is, make the transaction, and hang up. Things are going to go slower, but the customers can get their chewing gum because they want it. So that's now sometimes there will be a common service call, and that will be usually during some slow business hours, and there will be a scheduled failover test. You would go, be scheduled to whatever the store you have to go, and you will have phone number to call. The tech support from whatever the company is taking care of that service, and they would say, okay, we have a scheduled failover test. So you would just pull the plug on the network in the store and see if the modem kicks in to dialing and the communication happens. So you basically are creating a network failure and looking if because they're supposed to be happening automatically and looking if the things are working. So sometimes some of the stores have it once a month, sometimes once every 2 months or whatnot, just to make sure that the failover system works. So yes, dial-up modems is still being used, but not in the same way that used to be used some time ago. Now, I'm going to read all that stuff here, probably. Here's a typical small business setup. Here's equipment rack mounted to the wall, and here is the field wiring that goes to the individual desktop PCs, cash registers, whatnot, VoIP telephone systems, maybe. And all that field wiring. On one side, it has the jack on the wall, mounted to the wall, or some desktop. And on the other side is a dry connection. It's a patch panel, which is a bunch of jacks, but in the frame. And from here, there will be patch cables connected to a switch or a router. That switch is connected to another device. It could be gateway that has all the permissions and restrictions and all that programmed. And in that case, usually there will be modem put in a bridge mode, which means it doesn't modulate or demodulate. It just passes the signal raw, and the individual gateway is the machine, the device that carries all the restrictions, permissions, and routing thing. There could be another router or whatever. Here's a network kind of a setup. And look, there is that US Robotics modem. You can still buy that thing brand new, which when I was in that service business, doing the service calls of this type, it kind of became a bit sentimental because usually when you get that, you expect to be a vintage, yellow plastic or something like that, maybe some scratches. And I can see a brand new US Robotics model, V92. And I go, oh, wow. No, I got some memories kicked in. So, yeah. So things are being used as far as the dial-up. Okay. So that's as far as broadband connection. That's as far as broadband connection. That uses frequency division multiplexing versus baseband connection that utilizes time division multiplexing. This here, the link using broadband has to have a huge bandwidth because it has to accommodate all the channels at the same time, from the lower channel to a higher channel. And this is not just three, there could be 200 channels. And in the time-based baseband transmission, which utilizes different type of multiplexing, time division multiplexing, TDM, of course. And the link doesn't have to have. I keep forgetting this word today. As much bandwidth. What's going on with me today? All right. So that's as far as that. Also, what I needed to cover with you, I promised you that I was going to do, is the telephone features. Oh, no, they were here. Here are telephone features. Some, like quite a bit of them, we already have covered. You can still see my screen, right? With my mouse moving and the red dot. If you don't, let me know. I think we're still doing this screen share properly. Let's take a look at some of them that we maybe didn't have a chance to cover. Pulse and tone dialing. This quite often has something to do with programming the telephone system or programming the box that is called a telephone system to work the way that's intended. And between one business and the other, one client and the other, some of the programming might be slightly different according to the needs. Now, this pulse and tone dialing, this would be in the lines as telephone lines section of the programming structure of a phone system, as opposed to the sets. That means the telephone sets programming section of the telephone system. So this will be in the lines programming, pulse versus tone, or DTMF. Pulse would be utilized or used in the early days. Well, sort of early days, because in the early days, there would not be a dial tone. There would be no automatic dialing. It would just be, things would be patched manually by people. Now, with automatic dialing, where the dial tone was introduced, well, the way the telephone set communicated with the central office as far as to dialing the numbers, it would be by the pulses, sending pulses, and there would be just a line interruption with a certain speed. So the pulse would just sound like in that kind of line interruptions. And those pulses would be interpreted by the CO office, and it will be put in a sequence of whatever number is being dialed. And once the whole thing was dialed, then the number would be connected to you. The person with that number will be connected to you, and you would have a conversation. Later on, you would have something that's called DTMF. Each number would be represented by the tones. Okay. Dual tone multi-frequency dialing. Ooh, intimidating. Well, it will be frequency dialing because every number would be assigned to a specific frequency. But here was the challenge. When you would only have one frequency designated to one number, if you pick up the handset, There could be music going on in the background, TV, radio playing, people talking, and whatnot. And some of the frequencies could be interpreted as that exist in the music, in the song, or whatever. Uh, it would be they could be taken as a number being dialed. So that could cause some problems. So to remedy that, each number is assigned a dual tone, two specific frequencies. And when the receiving end sees that two of those specific frequencies at the same time, then it says, oh, number 3 was just pressed. That's how they can hear that, can hear that funny sound when you press those numbers. Common service calls with that would be, let's say the client would call and say, we could dial, no problem. We could dial the numbers and we get connected and we can talk. But when we get the menu to choose from hours of operations and and then, or if we can dial the extension, the number of the extension of the person, we keep pressing the buttons and nothing happens. Whatever the other side equipment is not reacting. That could be because the system could be either wrongly programmed. The lines could be programmed to act as pulse dialed lines instead of DTMF. Or sometimes there's a glitch. Maybe there's a power outage. Maybe there's some kind of a pulse that sends through enough to make a mess with some of the programming. And sometimes things switch to pulse dialing. So you just have to go in and reprogram those lines. Ground start and a loop start. Am I bored? Am I bored? Oh. So the windows open at the same time. There you go. I got my board. Here. Okay, let me erase with a sponge. There we go. What was going to, the ground start and the loop start. Now, all right. It beats me. Why is this option still available? When I explain that to you, you'll be wondering yourself. In the old days of the telegraph and later on telephone, you would have the utility poles with all the lines extending, right? Telephone lines extending through that. And it would be one line per phone connection. The other equipment, wherever it would be, lines would be coming through, and there would be other building, maybe on a different train station. The other side would be also connected to the ground. And the other thing would be also connected to the ground. So the ground itself was servicing as the other connector, other conductor. Relatively quickly, that idea was abandoned because you couldn't get too much of a good quality of a conversation or transmission using that. So instead of having one line, you could tell why this thing was done, because you only have one line per conversation instead of needing 2 lines per conversation, because right now, there's a telephone, and between those two, there is a pair of wires making a loop, closed loop. So nobody's using anymore those ground start. Where's the start word coming from? Is to initiate a connection. To start, they had to name it somewhere, somehow, and this is how they named it. It's them. Okay. But now loop start, the loop type of connection is, you have a pair of wires per every conversation. So when you go into the line programming, you still have the option of having a ground start, and quite often the ground start is set as a default when that thing should be eliminated. It's all loop start anymore. DOD, DID, direct outward dialing, direct inward dialing. It's a feature that is assigned to the phones as opposed to the telephone lines with the telephone sets or set programming within the telephone system. When you pick up the handset, you can have more than one thing happen, depending on the wish of the client, of how you want the phones to be set up. You can pick up the phone and there's absolute no reaction from the phone set. You can pick up the handset, none whatsoever, no reaction from the telephone set. Or you can pick up the phone and upon picking up the handset, you could say that I want the intercom dial tone to be present, which means you can make an internal call without selecting the button that says intercom and then get the dial tone. Or the client might wish, if I pick up the handset, I want an outside line to be selected. So the outside line to be selected, first available line that is available, that would be direct outward dialing or direct inward dialing if you get the dial tone from the internal system. No, you can change. If you get one, you can press the button and select the line, and there you go. But some people want it this way, some people want it that way. Now, also here's the hotline thing, which is direct inline or direct outward dialing with a specific number dialed automatically. So as soon as you pick up the handset, a number is being dialed, internal or external. Quite common thing for taxi companies. When you see in some large department stores, you would see by the entrances or exits, it would be a telephone without a keypad, just a handset. That would be a hot dial telephone, and those taxi companies would purchase the telephone line, purchase the installation, just so and sometimes you have more than one telephone on the wall because you have more than one taxi company, and all that stuff. 911. We talked about that. I'm going to kind of do a little bit of a refresher. A 911 telephone set is a telephone designated, or it has to be installed in some companies or some facilities, depending on what the law of the land is at that land, to be able to dial 911 if something happens. A very common situation for that telephone to be installed is large production halls. And usually there will be more than one 911 phones. It's a phone. It's just a single line telephone set, normal telephone connected straight to a CO line, telephone line, POTS line, bypassing any kind of equipment. And the purpose of that is if somebody needs to dial 911, there is the phone. In some cases, it's a mandatory to have one of those. Yes, everybody has a cell phone, but the owner of the company cannot assume that somebody's going to have a cell phone. All right. And of course, when installing those, there should be one telephone per one line. Because if you have a telephone, 911 telephone here connected to the same line as the other one on the other side of the production hall, they're far from each other. And if somebody doesn't hang up that phone, then this phone is useless. So one per line. Single line versus proprietary. Now it's 152 right now. And as I always say, if you need to go to another class, please do. You can catch this lesson, the end of the lesson, when it's being posted, as I always do. We have probably another 5 minutes to talk. All right. So single line versus proprietary. Single line is just a regular POTS type of telephone set, a telephone device. A proprietary telephone set is a telephone that works with a specific telephone system. So if you get a Panasonic telephone system or a Toshiba telephone system or whatever else, it will come with its own set telephone sets. That those telephone sets understand the signal from that box only. Plug it into the wall, the regular telephone POTS lines, it will not work. And vice versa. So that's a proprietary telephone set to whatever the system is. Now, MOH, music on hold. Why am I even mentioning that? Well, somebody was very clever with this one. Maybe I told you that or not already. Music on hold is, well, excuse me, sir, can I put you on hold? Yeah, sure. And then, you listen to that music, right? Until somebody decides to pick up the phone call again. And when we were installing those, usually would be like a radio receiver or something like that with headphone output, and you plug into the input of the music on hold of the telephone system and program the phone system to actually recognize that and play the music instead of the confirmation tones or beeps that you're still being on hold. That'll be an option. But somebody very smart got together with somebody else who is also very smart and say, hey, why don't we just do something? We can provide music on hold service. What's music on hold? Well, we contact the client and we say, instead of having the music on hold, if some clients of yours are on hold, why don't they listen to the advertising specific to your company? We could make an audio loop that lasts maybe 1 minute or 2 minutes and it just repeats itself. And we can connect that to your phone system with an audio output from our box to your box. It could be just on the wall right beside your phone system. And we can also connect that to the network. So we could log in from outside and upload a file when the file needs to be changed. So this month we are advertising this and that and the other thing. And next month we have specials on some other things. And this is a month of whatever. Remember to get your whatever. And that was done. It's done with a fee. So they got a lot of customers and monthly fee for the service and probably a fee for changing the file because that has to be prepared. There you go. Money. All right. So MOH service. Yeah. Dry contact. We talked about dry contact relay for the amplifier, audio amplifier. So the input of the audio amplifier for the paging is not on all the time. So besides the output, audio output from the telephone system, you also have a dry contact relay. And the PA system amplifiers, they will have a couple of terminals that if joined together, if shorted, then it enables the input, the audio input, so the page can be done. So the telephones, you can do a page, it sends down the signal through the audio output, through its audio output, and it closes the relay for the time of the page. So when the page is done, the input of the amplifier is not wide open to pick up any noise and interference and just play plain old hiss or hum, annoying through the phone, through the speakers, through the paging speakers. PI stands for paging interface. We went over that. Not going to repeat that. We're already familiar with this type of device or with this type of device's existence. Okay, let's be honest. CO, central office, we talked about that. SL stands for single line, usually referred as POTS. And you can have SL sets, SL telephone set, which means a telephone set that understands POTS. Rollover, okay. Rollover goes quite often with the ELEC number. Now I gotta give you some board here. Um, Erase. Let's say a company has purchased line 1, line 2, line 3, line 4, and line 5, and line 6. All right, so these telephone lines, CO lines, could be SIP lines, but let's talk about CO lines. They could be, well, let's say, okay, we have so many people in the offices, and we would need 5 telephone lines for us to comfortably have our business going. All right, but can you put those lines, and this is when ordering the lines from the telephone provider, can you put them in a rollover sequence? What does that mean? That each line telephone that is purchased has its own number, own telephone number. But you're not going to publish all the phone numbers, all 5 phone numbers. You want to publish only one. What if the company has 100 lines? Well, what do they do here? What if the company has 100 lines? You're not going to publish 100 lines. You just want to choose one of those numbers, and usually it will be line 1, to be published. And what happens if a client calls that published number, it will try to ring that line. The system will try to ring that line from the outside. If somebody is talking on that line is busy, it will jump and try to ring this line. And this one is busy, it will try to ring this one, and then this one, and then that one, and then all over again. So it's a rollover sequence as far as line hunting from the central office from outside. Of course, on the inside, you would have what's called a hunt group. You would include some of those telephone lines that those are connected to in a hunt group. So if you press 9, it will select the first available line within those, but that's on the inside. But rollover comes from the outside, and it's programmed by the telephone provider. You order them in such a thing. Now let's see, why do I put line 6 here? Because that thing can go to a fax machine, for example. Some companies still do. But the company has 6 lines, 5 of which are in the rollover sequence, and one of them is dedicated to fax. Sometimes, if somebody is connecting those lines, they could mistake and they connect them wrongly. So we connect line 4 instead of fax line and fax line 4. It will create certain type of disorder when it comes to certain phone calls from clients. I'm talking about the cross-connecting lines on the BICS block towards the phone system or towards the fax machine, for example. So sometimes you have to play some detective when you go to troubleshoot things. But that's in the future. If you ever get the job, if you decide to work for this type of business. Now, there comes the challenge with this. Because if you want to troubleshoot that, you're going to have to find out what all those numbers are and make sure that they are connected into the appropriate terminals. But the problem is that if anybody picks up any of those lines, and they'll be including you, it would clip on with the diagnostic set onto that line at the communications room. And you're going to what? Dial your cell phone number to see what number you're calling from, right? Well, wrong, because if the line is within the rollover sequence, it is not going, your cell phone is not going to display the line you're calling from, it's going to display the published number. That's why there is something that's called the ELEC number. It's automatic number announcement circuit. Most of the companies have that number. Like, for example, for Bell Canada in our area, if you have the telephone line from Bell Canada, if you get it from Rogers or from somewhere else, then this number will not work. This is just for Bell. if you pick up the phone and you dial the area code that you're in, and then dial this number, you're going to get a voice annunciating the number actual of the actual line that you're clicked onto, not the published number. So it's a diagnostic kind of a service thing. Okay. So that's as far as the rollover sequence and the ELEC number. KSU, key system unit or key service unit, we talked about that. POTS, plain old telephone service. All right. Tip and ring, talked about that. ATA, we talked about that. Register jack, we talked about that. Now the trunk and the and the battery present. Let's talk about trunk first. Very simple. A trunk is a cable that contains many cables or many telephone lines. So within the big service companies, they would say, okay, this is a trunk that services certain neighborhood. That's what trunking is, bundling the cables. Then battery present. We talked about the ringing and the ringing voltages. The video is included that I made. The video is included in the our YouTube playlist. When troubleshooting a regular POTS telephone line, let's say just a plain old telephone service, POTS, what do you need to know? Is there a dial tone? Oh, no, there's no dial tone. Okay. Well, there could be some dial tone circuitry trouble at the provider's end. But you're going to say, oh, is the battery present? Because it's a completely different circuit that services that 48 volts or negative 48 volts onto the telephone line. And so if there's no dial tone, but the battery is present, which means there's a 48 volts DC on those lines, that means that there's some kind of internal problem with the provider's telephone circuitry. But if there's no dial tone and there is no battery present, no voltage, then the chances are that some backhoe dug in and broke the line somewhere. Right? That's how you use the detective mind. Yeah. Okay, so we have gone over the broadband and baseband transmission systems, and we finished up the telephone system features just so you could understand some of that, depending if whether you want to go into this business or not. You got some pretty good base startup knowledge when it comes to this. And for the class of right now, this is the class of 2025 summer, I'm going to release the test tomorrow, which is Friday. And it's going to be same as all the other tests we're writing. Tomorrow, Friday, I have in-person class with the sections, I think sections 3 and 4, which is not you. However, because we have lost Monday because it was a holiday, that means I cannot deliver a class to half of the class and not the other. So there's going to be no new theory content for our in-person class tomorrow, but I will be there in class. If anybody needs to clarify some things, talk about whatever you want to talk about, well, school-based. So I'll be there, and if nobody shows up in the first 15 minutes, then the session will be closed. So that's it for today. Ladies and gentlemen, thank you for your attention and have a wonderful day.